Okay, next up, after displacement and velocity, is acceleration. Okay, and you see how kind of a pattern arriving of displacement is a change in x, velocity is a change in x over a change in time, and then acceleration is a change in velocity over a change in time. And that's kind of our main equation there for acceleration. It's your velocity, or sometimes referred to, actually wrong, but as a change in speed over a change in time. Depends on if there's a direction tied to it or not. So if we got this car, let's just say it's just the brakes are on, it's just parked, and then it accelerates up to 10 meters per second in 2 seconds, right? So its speed is changing, its position is changing, but its speed is also changing, its velocity is also changing. And like I said, just following our equation, it's a change in velocity, which is final minus initial. At the end, we're going 10. We started off at 0. So it's 10 meters per second over 2 seconds. Notice our units, once we solve that, is meters per second squared, okay? 5 meters per second squared. Make sure you don't get confused with that second squared on there. That's not it doesn't affect the number. Like this is 10 divided by 2. That's the number, that's the magnitude. The units, that squared is separate. It's kind of hard to conceptualize, but it is in fact, the correct units. And as you get more comfortable with these problems, you can literally solve them, as we get into more complicated problems involving displacement, velocity and acceleration. Understanding the units for each of them is very, very important. Once again, what if we started to slow down then? All right, so let's take this problem and let's say after this point right here, we start to slow down until we hit the brakes and we're not moving at all at velocity equals 0 meters per second. What's going to happen there is, so if we look at, let's say it took another 2 seconds to do that. So let's just look at, so now we have this, but let's call this our new initial point. Okay, so we're starting off at 10 meters per second and ending at 0. So if we were, and it took 2 seconds. So if we solve that, once again we get 5 meters per second squared. However, it is negative. And once again, a negative just tells us the direction of the acceleration. In this case, the acceleration is in the opposite direction of the motion. That can happen. And that just means that we're slowing down if it's negative.